According to this question, the existing cable and the new cable, they are going to intersect. And for the existing cable, I'm going to call it LC. And for the new cable, since it passes through points P and Q, I'm going to call it LPQ. At the point of intersection is when the two lines are going to intersect also. So what I'm going to try to do is to form the equation of the line LC, form the equation of the line LPQ, and I'm going to let them intersect. And at the point of intersection, that is when I can find enough information to solve for this unknown A. So for this line LC, its equation will be R is equal to the position of vector of a point that LC passes through. Obviously, I'm going to make use of the origin. So 0, 0, 0 plus lambda of a direction that is parallel to LC. According to the question, it is parallel to 3, 1, minus 2. So what I have is just a lambda of 3, 1, minus 2. As for line PQ, since it passes through P and Q, let's find a direction that is parallel to this line by finding first the vector PQ. PQ will be OQ minus OP. OQ will be 5, 7A minus away OP, which will be 1, 2, minus 1. And this will give me a 4, 5, and A plus 1, which means that the line that passes through PQ, the equation will be R is equal to, let me make use of the position vector of P, so it is 1, 2, minus 1, plus, let's say, mu of 4, 5, A plus 1, since PQ is parallel to this line. So at the point of intersection, that is when the R and the R of the two cables, they are going to intersect. Of the two lines, they are going to intersect. So let's try to solve this as a pair of simultaneous equations, letting this R be equal to this R. So this, at the point of intersection, it will be 3 lambda, lambda, and minus 2 lambda. And as for this, it will be 1 plus 4 mu, 2 plus 5 mu, and minus 1 plus mu of A plus 1. Making use of this and this equation, let's try to solve for lambda and mu first. For this equation over here, we have a 3 lambda is equal to 1 plus 4 mu, or we can also rewrite this as 3 lambda minus 4 mu is equal to 1. This will form for me my first equation. As for the second equation, lambda here is equal to 2 plus 5 mu. This tells me that lambda minus 5 mu is equal to 2. This will be my second equation. Solving for these two equations using my graphing calculator, I will be able to solve for lambda and mu. Lambda is going to be equal to minus 3 over 11. And as for mu, it is minus 5 over 11. Which means that this and this should satisfy this equation also. So for this last equation over here, we have a minus 2 lambda is minus 1 plus mu of A plus 1. And we do know that at the point of intersection, lambda is equal to minus 3 over 11 is equal to minus 1 plus mu. Mu is minus 5 over 11 of A plus 1. This will then help me to solve for A. A is going to be equal to minus 22 over 5.